Hi, everybody. It's Professor Mitchell. We're starting chapter 11 today on quadratic equations and functions. So let's start with section 11.1, which is solving quadratic equations by completing the square. First, we'll talk about the square root property to solve quadratic equations. Then we'll solve quadratic equations by completing the square. And finally, we'll use quadratic equations to solve problems. And now we're working on SLOD, which is solve linear and nonlinear equations and inequalities, including radical, exponential, and logarithmic functions. All right, so the square root property can be used to solve an equation like this, x squared equals 49. So let's go over how would we have solved this equation in chapter 6, and how will we solve it now. So going over to the tablet. In chapter 6, what we did was we put all the quadratic equations in standard form, and then we solved them by factoring. So for this equation, we would start by doing minus 49 on both sides, which would give us x squared minus 49 equals 0. And you remember how to factor this thing, x squared minus 49, that's a difference of two squares. So that's going to factor as x minus 7, x plus 7 equals 0. And of course, if x minus 7 times x plus 7 equals 0, that means one of those two things is 0. If x minus 7 is 0, that means x is 7. And if x plus 7 is 0, that means x is negative 7. So this equation has two solutions, which are 7 and negative 7. All right, so now I think this new way is quite a bit simpler. So the idea is you look at this equation, x squared equals 49. So think of that like this. I'm thinking of a mystery number that when I square that number, I get 49. All right. Now, the only disadvantage of doing it this way is everybody's going to get the 7, but some people are going to forget the negative 7. So the way that you want to write this, and hopefully this will become habit, is you say x squared is 49. That means x has to be either the positive or negative square root of 49. And of course, the square root of 49 is 7. So you get the same two solutions. Took me a lot less time to get it that way. You just have to remember that plus or minus. All right, so let's make this official. Another advantage of doing it the new way is that you can use it to solve equations like y squared equals 20. All right, that equation cannot be solved by factoring, at least not any kind of factoring that we talked about. All right, so here's what the square root property says. If b is a real number and a squared is equal to b, then a has to be either plus or the positive or negative square root of b. A has to be plus or minus square root of b. All right, so here are the examples that we're going to look at next. So let's go back to the tablet. All right, starting with the square of y minus 3 equals 4. So the first step with using the square root property is to isolate the expression that's being squared, which is already done. So this actually turns out to be pretty simple. If the square of y minus 3 is 4, then that means that y minus 3 has to be either the positive or negative square root of 4. So of course that means y squared is either positive or negative 2. So the only extra thing that I have to do in this example is now I have to get rid of that minus 3. So we'll add 3 to both sides. And that is going to give me y equals 3 plus or minus 2. In other words, 3 plus 2, which is 5. and 3 minus 2, which is 1. So the solutions of this equation are 5 and 1. So hopefully you'll recall from chapter 6 that quadratic equations usually have 2 solutions. What never happened in chapter 6, though, is that sometimes the solutions will be non-real numbers. So you're going to see an example of that coming up here pretty soon. All right, next example. And again, you've heard me say it 100 times. At any point that you want to pause the video and try one of these and then come back and compare notes, I always encourage you to do that. All right, so if the square of 4x plus 9 equals 6, that must mean that 4x plus 9 is either the positive or negative square root of 6. So now we have to solve this equation for x. First thing I'll do is subtract 9 from both sides. And that is going to give me 4x equals negative 9 plus or minus the square root of 6. And then we have to divide both sides by 4. All right, so x is negative 9 plus or minus the square root of 6 all over 4. And when you put these answers into your online homework, I believe it's going to want you to write both solutions separately. So whenever you see a plus or minus symbol, that means there are 2 solutions. Plus or minus is just sort of lazy shorthand notation. All right, next example. The square of y minus 4 plus 18 equals 0. So remember what I said at the beginning of part A. The first step is to isolate the expression that's being squared. So in this case, we have to start by subtracting 18 from both sides. And that's going to give us the square of y minus 4 equals negative 18. All right, so if the square of y minus 4 is negative 18, that means y minus 4 has to be either the positive or negative square root of negative 18. Now, before you just put down your pencil and say, okay, that's not a real number, well, we now know about complex numbers. So complex number solutions are okay when you're just solving an equation. There are certain instances where they don't make sense. For example, in a word problem, usually it's not going to make sense. And also in a graphing problem, there's really nothing you can do with non-real numbers. But this is just solving the equation, so we will include these 2 non-real solutions. So first, let's simplify the square root of 18. You remember how negative 18. Remember how that worked from the last section? I'm going to write that as negative 1 times 9 times 2. The square root of negative 1 is I. The square root of 9 is 3. And the square root of 2 is just the square root of 2. Okay. So let's write that as plus or minus 3i square root of 2. And then finally, I will add 4 to both sides. That gives me my 2 solutions are 4 plus or minus 3i radical 2. And remember, there are 2 solutions there. One solution is 4 plus 3i radical 2. The other solution is 4 minus 3i radical 2. All right. Going back to the presentation. Oops. Okay. Almost had a spoiler there. Okay, so at this point, I do want you to pause the video and try to solve the equation y squared minus 8y plus 34 equals 0. And I'll see you back here when you're done. Okay, so hopefully you tried that and you nailed it, right? Or did you have a little trouble? Where this is the point where I usually tease you and I say, well, what do you mean you had trouble with that? You just did it. All right, but I'm just teasing, I promise. Okay, well, kind of and kind of not. So you take y squared minus 8y plus 34 equals 0. The first thing I'm going to do is subtract 34 from both sides. Okay, so that's going to give me y squared minus 8y equals negative 34. All right, so next I'm going to do the obvious thing. And I know you all did this. I am going to add 16 to both sides. 16. Okay, well, that's the part where I'm teasing you. I don't expect if you did come up with plus 16, I'm really impressed. All right. But I didn't really expect you to come up with that. Okay, I'm doing a magic trick for you. All right, so now I have y squared minus 8y plus 16 equals negative 18. And now I'm going to factor y squared minus 8y plus 16. And look at how that factors. It factors into y minus 4 squared. Okay, so the thing that you saw come up for a split second when we were back in the presentation. See, I told you just did it. Y squared minus 4, or I mean y minus 4 squared equals negative 18. That's the problem we just did. All right, but it came originally written in a different form. So that's why you may have had trouble with it. We just did this problem. No need to do it again. The solutions are still going to be 4 plus 3i radical 2 and 4 minus 3i radical 2. Okay, so a good magician never reveals his tricks. Fortunately, I'm not a good magician, so I'm going to tell you how I came up with this plus 16. And that is called completing the square. So let's go back to the presentation. I mean, you can kind of see, let me go back there real quick. Hopefully you can kind of see why it worked out that I had the y squared minus 8y plus 16 right here, because that allowed me to factor that trinomial into y minus 4 squared. I needed it specifically to be a perfect square trinomial, all right? Because only if I get it to factor exactly like this will I be able to use the square root property. So what I'm going to show you right now is how can you do that with any quadratic expression that I might spring on you. Okay, so here are the steps to completing the square. We're going to do 4 examples of this, okay? Step 1, we're going to write the equation in the form x squared plus bx equals c. So let me tell you what's involved with that. First of all, if there is a leading coefficient other than 1, you want to divide that leading coefficient out. And the other thing that's helpful is to move the constant term to the other side of the equation. Okay. All right, so now here's the part that I call the magic trick. You take the coefficient of x, which is the number that I am calling b, this number right here. You're going to take that number, you're going to divide it by 2. So let's think about how this looked with the example we just did. So in the example we just did, this number was an 8. So step 1 would be 8 divided by 2, which comes out to 4. And then you're going to take that number and you're going to square it. So again, in the example we just did, you take the answer, which is 4, you square it, and that's how I got the 16. All right, I just didn't tell you ahead of time because I wanted it to look like magic. You're going to add that number to both sides, which you saw me do in the last example. And then you're going to factor the left-hand side. If you've done all the previous steps correctly, what you'll have on the left-hand side will be a perfect square trinomial. And then you can solve that equation using the square root property. All right, so here are the examples that we're going to do with completing the square. All right, so let's switch over to the tablet. All right, first example, x squared minus 2x plus 2. So remember the first step, write the equation in the form x squared plus bx equals c. So in this case, we're just going to take this minus 2 and move that over to the right side. X squared minus 2x equals 2. All right, so now it's time for the magic trick. I'm going to take the coefficient of x, which is negative 2. I'm going to divide it by 2, which gives me negative 1. And then I'm going to square the answer, which gives me 1. So the magic number is 1. I'm going to add it to both sides. And that's going to give me x squared minus 2x plus 1 equals 3. All right, so when you factor x squared minus 2x plus 1, it factors as x minus 1 squared. Remember, you need that trinomial to be a perfect square trinomial. All right, so now using the square root property, if the square of x minus 1 is 3, that means x minus 1 is either the positive or negative square root of 3. Adding 1 to both sides, you get that x equals 1 plus or minus the square root of 3. So there are two solutions to this quadratic equation. 1 plus the square root of 3, 1 minus the square root of 3. All right, next, 2y squared plus 12y plus 3 equals 0. So again, we want to write this in the form y squared plus by equals c. So two things involved with that. Number one, we have to get rid of this 2. All right, so the way we're going to do that is we are going to divide every single term in the whole equation by 2, which is going to give us y squared plus 6y plus 3 halves equals 0. And then we're going to subtract 3 halves from both sides, which gives us y squared plus 6y equals negative 3 halves. All right, time for the magic trick. Take the number attached to the y, which is a 6. Divide it by 2, which gives you 3. Square that answer, which gives you 9. So I'm going to add 9 to both sides. Y squared plus 6y plus 9 equals negative 3 halves plus 9. All right, so I have a feeling that some people would stumble on this part here. Negative 3 halves plus 9, you need a common denominator, which would be 2. Think of this as 9 over 1. Write that as negative 3 halves plus 18 halves, which gives you 15 halves. And when you factor y squared plus 6y plus 9, it factors into y plus 3 squared. All right, so using the square root property, I think I'll just make some room up here. Using the square root property, if the square of y plus 3 equals 15 halves, then that means y plus 3 has to be the positive or negative square root of 15 halves. Now, when we went over section 10.5, I very briefly mentioned that it's not considered simplified to have a whole entire fraction under a square root. You can rationalize the denominator. All right, so I'm going to do that off to the side over here. Square root, let's just carve out a corner here. Square root of 15 halves, I'm going to write that as square root of 15. And don't misunderstand, this is hardly the most important thing in the problem. All right. If you were doing this for me on paper in a regular class and you didn't do this part, I might not even take off. But the online homework, as you know, can be kind of picky. All right, so multiply the top and the bottom by the square root of 2. And that is going to give you square root of 30 over 2. So that's how I'm going to write that. Y plus 3 equals plus or minus square root of 30 over 2. And now when you subtract 3 on both sides, you get your two solutions are negative 3 plus or minus the square root of 30 over 2. And I think this time I'll just leave my answer like that instead of separating it into the two separate answers.